All right, welcome back. We are here for some more circle theorems. So we are going to look at the measure of external angles formed by tangents and secants today. So far we've looked at internal angles, right? So angles like central angles. We've looked at inscribed angles, and we've also looked at interior angles like this, right? We did that yesterday. And we also looked at angles on the circle, like inscribed angles, but also angles formed by something like a tangent and a chord, right? So like this angle, we know the relationship is half the measure of that arc, right? And same thing for this angle. That angle would be half the measure of that intercepted arc. So we've looked at angles inside the circle and on the circle, and today we're going to be looking at angles outside of the circle. So angles external or exterior of the circle. All right, so we got three scenarios we got to take a look at. And so get out your calculator, see if you can follow the steps of lab number 1. I'm also going to be doing lab number 1 on the TI Inspire. And to save some time, I'm going to be doing labs 2 and 3 on Geometer's Sketchpad. So let's take a look at the calculator first. And ignore all of that. So first step says construct a circle. So menu shapes. Let's make a circle. Construct a tangent line to the circle. So we've done this a couple of times now. Hopefully remember how to construct a tangent to a circle. All right, to get the tangent, we're going to make first a, all right, very good, a radius, right? Because we know tangents to a circle are perpendicular to radii or diameters at the point of tangency. So next, I'll construct a I did bisector by accident. Menu, construction, perpendicular. And so there is my tangent line. I can move that anywhere I want. Let me hide the radius. Whoops. Menu, actions, hide. Right. So there's my tangent. From an external point on the tangent line, construct a secant. That is the next step. So I'm going to pick an external point on the tangent line. And from that point, I will make a secant. So we all remember what a secant is, right? It intersects the circle 1 time, 2 times. So I'm going to make the endpoint just on the circle. Why not? And there we go. So the angle formed by this tangent, right, and the secant should intercept 2 arcs, right? It makes this arc over here and this larger arc over here. So let's try to see if there is a relationship between this external angle that's formed and these 2 arcs. So let me put another point at that intersection point. And let's start measuring. So measuring this angle, that is 40.5 degrees. To measure the 2 arcs, we need to draw in the arcs first. So go to circle arc. And remember to put a point in between. Same thing for this arc here. And again, your calculator can't measure arcs in degrees. It can measure the arc length though, which we can change to degrees. So there's that arc length. There's this arc length, right hit tab. And here is the circumference. So to get those arcs in degrees, I gotta do some calculations. So menu, actions. We're gonna do A over B times 360. And let's call this C over D times 360. So calculate. All right, so let's say I wanted to get this arc here in degrees. Someone tell me what calculation I would do. All right, very good. I will make this A, 14.1 divided by the circumference, 31.8, times 360 degrees tells me that arc is 160 degrees. All right, now for this calculation, menu, actions, calculate. I'll take the arc length 6.93, again divided by circumference and multiply by 360 and get 78.4 degrees. So at this point, I would ask you to talk with your neighbor and see if you can come up with a relationship between these two numbers. All right, it's kind of hard, especially with the rounding, because it's going to be off a little, but see if you can see some relationship between these three numbers. All right, this is a little challenging, but hopefully playing around with it, if you look at the numbers, we should see that this number minus that number divided by 2 is 30.8. All right, so this angle, this exterior angle, is going to be equal to 1/2 the difference of these two arcs. And let's take a look and see if that calculation holds. So I'm going to make a new expression. Let's call this x minus y divided by 2. And actions calculate. So I said it was the difference of these two arcs. So x minus y will be the bigger arc, 128 degrees, minus smaller arc, 66.2 degrees, divided by 2. And that gives us this value, 30.8 degrees, which is right there. That is 30.8 degrees. Fantastic. All right, and if we adjust it, we can see, there you go. These are some nice numbers. 150 minus 90, right, is 60. 60 divided by 2 is 30. Right, x minus y over 2, 30 degrees. So, of course, the rounding, but that is going to be our relationship. All right. So let me go back to my iPad. And we have just shown that relationship for the external angle formed by a tangent and a secant. You're going to repeat the same thing for labs 2 and 3, except for lab number 2, you're going to be doing 2 secant lines. So that's going to look something like this. All right, so if you want to try this on your calculator, you're going to be measuring this angle and these two intercepted arcs. See if you can find a relationship between those three guys. And for lab number 3, instead of secants, we're going to be doing 2 tangents. So maybe something like that's a tangent. And let's say there's my other point of tangency. That would be my other tangent. Right, in this case, there's our exterior angle, and here are the 2 arcs, one arc and the second arc. All right, so if you want to try those, see what you get. I will be doing that now on Sketchpad. So hold on, turn that, open that first, and preview. There we go. All right, so for lab number 2, we got 2 secant lines. It's much, much faster on here. All right, those are my 2 secant lines. And let's measure this angle. Click, click, click. Measure of angle ABC is 21.77 degrees. Let's measure, let's move that one away. Let's measure this arc length. Click there. Let's measure, not the arc length, sorry, the arc AC in degrees. That arc angle is 101.59 degrees. And let's measure this other arc. I don't think oh, thank goodness. All right, there we go. I don't know if I got the point of intersection or not. There we go. All right, if you measure this other arc, that's 53.15 degrees. Again, notice anything between the 2 intercepted arcs and this exterior angle? Well, I will show you that that is equal to this arc minus the smaller arc divided by 2, and that is 24.22 degrees, 24.22 degrees. Wow, fantastic. And as always, I can move the points around, and that holds true. Right, and for lab number 3, we got 2 tangent lines. So to draw my tangent lines, I'll be constructing two radii and making the perpendiculars to those radii. Perpendicular line, perpendicular line. Here is my exterior angle way out there. But let's see if this is also true for two tangent lines. So there's our angle. I'm going to have to add an extra point here because this is a major arc. It's more than 180 degrees. So when I click, I have to click all three of those points to get that arc angle. And that's good. That's more than 180, right? 200 degrees. This angle here, measure arc angle. That's 158. Right, these two numbers should add up to 360 because that makes a full circle, right? And if I calculate the bigger arc minus the smaller arc times a half or divided by 2, well, 1/2 the difference of the two intercepted arcs is equal to the measure of the exterior angle formed by two tangent lines. And I'll just move the points around a little, and we can see, wow. All right. So let's get back to our notes. So we have just shown in all three cases the measure of an angle formed by, sorry, this A should be over here, formed by a tangent and a secant, or formed by two secants or two tangents, intersecting outside a circle is equal to 1/2 the difference of the two intercepted arcs. All right, yeah, some good stuff. So in other words, if you want a diagram for each case, here is the case with a tangent and a secant. Right, if I call this external point, point P, well, we can say that the measure of angle P is equal to, let me label these points, A, B, and C. Well, that's going to be equal to 1/2 the measure of arc AB minus the measure of arc AC. Right, the difference of the two intercepted arcs. So it's kind of opposite from what we did yesterday, right? What we did yesterday when we had two chords intersecting inside the circle is these arcs were the average of those two arcs. Sorry, not this arc. This angle measure, right, was the average of these two arcs. So we would sum the two arcs and divide by 2. So when it's on the inside, you add them. When it's on the outside, you subtract them. It's the difference. All right, and of course, the same thing if this is angle P here, right? It's going to be the difference of those two arcs. I don't feel like writing that out. And if it's two tangents, you get a nice tangent over there, right? Measure of angle P, again, it's the difference of the bigger arc minus the smaller arc divided by 2 or times a half. Right, so for all three cases, we're going to be using this theorem. So that is very nice, but we only show this on a calculator. We can't use this until we prove it. So don't worry, we're not going to be doing all three proofs today. I'm just going to be proving one instance. And then here are some guided notes for you. You're going to see the same thing on your homework. You can just copy and paste it over if you want to do it on your notes. But I want you guys to finish the other two cases for homework. So the case we're going to do together is one with a secant and tangent. All right, so for homework, you're going to be doing the case with two tangents and two secants. So given circle O with tangent BC and secant AD, what are we trying to prove? Well, the theorem says that this exterior angle angle B, that's going to be half the difference of the two intercepted arcs. So the difference, we're always going to start with the larger arc. So that's going to be the measure of arc AE minus the measure of the smaller arc ED. All right, so let's write this out. Step 1, that's going to be your givens. So let's start at step 2. So let's pretend we don't know the relationship yet. So we need to draw some other angles that we do know the theorems for. So what might make sense to draw in is something like AE to the point of tangency, right? Because don't we know the relationship for a tangent and a chord, right? Don't we know the measure of this angle is half its intercepted arc? And also when we draw an AE, we've also created a inscribed angle here, right? And don't we know inscribed angle, angle A, is going to be half the measure of ED. And both of those angles involve the two intercepted arcs that are in our theorem. So this is a very good construction to make. So my first step of this proof after the givens is going to be to construct this chord AE. So I'm going to construct chord, what was it, AE. Right, and we all know the reason between any 2 points, only one line segment can be drawn. So I'm going to be taking a look at this angle here and this angle. So how do these two angles relate to the angle where we are interested in, angle B? Well, this is an exterior angle, so that means that should be equal to the sum of the two non-adjacent interior angles. So can't I say that? And these are not equal, by the way. I'm just marking the angles that I'm interested in. So this angle and this angle. So step 3 is I'm going to say that the measure of angle CEA is equal to the measure of angle A plus the measure of angle B. Right? Again, this angle is equal to this angle plus that angle. Right? And that theorem is the measure of an exterior angle in a triangle is equal to the sum of the two non-adjacent interior angles. So let's solve for the measure of angle B, because that's the angle that we are interested in. So let's say the measure of angle B is equal to the measure of angle CEA minus the measure of angle A, and that's just subtraction postulate. All right, step 5. Well, what is the measure of angle CEA equal to? So measure of angle CEA, this angle right here, that's going to be half the measure of arc AE. That's half the measure of arc AE, right? And that was from a previous theorem. Did we do that yesterday or before the weekend? I don't remember. But that theorem says, right, a tangent and a chord to the point of tangency form an angle that is 1/2 the measure of its intercepted arc. So I'm not going to write all of that out, but that was a theorem we showed. Step 6, well, what is this other angle? What is the measure of angle A equal to? Measure of angle A, that's going to be half the measure of ED because that's an inscribed angle. And we know inscribed angles are half the measure of their intercepted arcs as well. So the measure of angle A equals half the measure of its intercepted arc, and that's arc ED. All right, so again, the reason is an inscribed angle is half the measure of its intercepted arc. And now step 7, doing a substitution, I can take this, plug it in for right there. I can take this, plug it in for the value for measure of angle A, and I get that the measure of angle B is equal to 1/2 the measure of arc AE minus 1/2 the measure of arc ED. And finally, if you jump straight to here, I wouldn't really mind, but we can factor out the 1/2 and we can have it look exactly like our proof statement. Right, 1/2 the difference of, sorry, I did not factor out that second half, 1/2 the difference of the two intercepted arcs. And the reason for this, you can just write GCF factoring or something like that, or factor out the 1/2. But there we go. Right? This exterior angle is equal to 1/2 the difference of those two arcs. Very cool. So these two remaining proofs are going to be very, very similar. So this one is even just fill in the blank. So take a look at this proof if you need some guidance, but very similar stuff. I even tell you which thing to construct, and we're going to get some inscribed angles once we do that. So I'm sure you can handle this. And this case with the two tangents, again, very, very, very similar. So there is a corollary theorem for an external angle formed by two tangents. And let's see if we can get there just by taking a look at a couple of problems. So for example, if I told you that this minor arc from there to there, if that minor arc had a measurement of, what does that look like? Let's say 100 degrees. All right, could you tell me what the measure of this exterior angle is going to be? So the answer is, if you calculated it, it's going to be 80 degrees. What if I had another circle, and again, two tangents, and let's say this angle here is 40 degrees. What is this going to be? Well, that's going to be 140. So I don't know if you notice anything, but these two angles are going to be supplementary, or the measure of those two degree values are going to be supplementary. And let's do a quick proof of this and see how we can get that. So this is a corollary theorem for external angles formed by two tangents, and this is only for two tangents. All right. So let me draw in two tangents again. Here's one tangent. Here is another tangent. And let's say they intersect at this point of tangent, sorry, this external point P with points of tangencies at A and B. So to make this simple, I'm going to call this minor arc AB X. So let the measure of, or let X equal the measure of arc AB. Well, if that is the case, what is major arc AB going to equal? So I'm going to add an extra point just so we can name this arc easier. I'm going to add another point, let's call this C. And that's going to be arc ACB. What is that going to equal? All right, very good. So that's going to be 360 minus X, right? Because we know the entire circle has 360 degrees. So if this piece from there to there is X, then this must be 360 minus X for ACB. So let's apply our theorem now. We can say the measure of angle P is going to be 1/2 the difference of those two arcs. So the bigger arc, 360 minus X, minus the smaller arc, X. And we get the measure of angle P equals 1/2 of 360 minus 2x. Measure of angle P equals 180 minus x. We distribute. And yeah, that's pretty much it. If we want, I'm going to replace x with what it was equal to. That was the measure of arc AB. So the measure of angle P equals 180 minus the measure of arc AB. And so in other words, the external angle, P, and the smaller intercepted arc, when you add them together, that's equal to 180. They are supplementary. So a corollary theorem for external angle formed by two tangents is that the exterior angle formed by two tangents and the smaller arc, when we added those two guys together, we got 180 degrees, so we can say those two measurements are supplementary. And the smaller arc are supplementary. All right, so we did a couple more circle theorems. We have a lot of them together now. So I just want to just quickly review all of our circle theorems. Not all of them, but at least the ones involving angles. All right, so we got central angles, which is equal to the measure of the intercepted arc. We have inscribed angles, which is half the measure of the intercepted arc. We got angles that are formed by a tangent and a chord. And these angles, right, that's half the measure of its intercepted arc, just like inscribed angles. We got angles formed by two chords in the interior of a circle. So let's say these are our two chords, right? We know this angle here, that's equal to half the sum of those two intercepted arcs. Same thing, if you looked at this angle, that's going to be half the measure of the sum of those two intercepted arcs. Right, and finally what we did today, when we have exterior angles formed by two tangents, two secants, or a tangent and a secant, it's half the difference of the two intercepted arcs. So I know it's a lot, which is why I recommend writing all of these down in one place and just adding on to it as we get more. So I want to do a problem. I'm just going to make one up real quick. Let's see, I have it somewhere. And so let's take a look. So let's do one example. So let's say given circle O, and let's say we have a tangent PQ, and we have a secant, let's call it PRS. All right, so given this diagram, and if I told you that the measure of arc QR to the measure of arc RS to the measure of arc SQ is equal to a 2:3:4 ratio, I want you to find the measures of all the angles and all the arcs in the diagram. All right, and also I'll draw in QR. So I want you to find the measures of angle P, angle PQR, angle PRQ, right? This angle QRS, and the measure of all the arcs that you can in that diagram. So that's going to be our example for today. That goes over the theorems we talked about. So first of all, if I know the ratio is 2:3:4, well, I can set up a ratio of 2x, 2:3x, 2:4x. So I'm going to call QR 2x. I'm going to call RS 3x, and I'll call SQ 4x. And now I can solve for x by saying 2x plus 3x plus 4x. Well, all of those arcs, they have to sum up to 360 degrees because they form a full circle. So solving, we get 9x equals 360, or x is equal to 40 degrees. All right, so now I have the length of each one of these arcs. This arc here is 120 degrees. This would be 80 degrees, and this would be 160 degrees. So now using our theorems, let's find the measure of angle P here. Well, that's going to be half the difference of the two intercepted arcs. So the measure of angle P is going to equal 160 minus 80 divided by 2, or times a half. All right, I'll do the times a half version. So measure of angle P is half of 80, which is 40 degrees. All right, so that is 40 degrees. How about the measure of PQR? Well, can't I just take, that's a tangent, right? This is a chord. Oh, I think I did something wrong. Did I do something wrong? Something doesn't feel right because, right, x is 40. All right, and QR was 40 degrees, 280, 360. Yeah, that checks out. So what's the measure of PQR? Hold on, why is this feeling weird? Oh, okay. I'm sorry, I confused myself. I thought that QRP was 80 degrees, and I was doing sum of angles in a triangle and it wasn't adding up to 180, but this angle here is not 80 degrees. All right, so the arc was 80 degrees. So PQR is going to be half the measure of that intercepted arc. So the measure of angle PQR, that's also going to be half of 80. That's going to be 40 degrees. And lastly, let's find the measure of angle PRQ. So if I want to try that, PRQ, that's just going to be adding the angles up to 180. So if that's 40, and this guy here is 40, then PRQ is going to be 100 degrees. Right? An alternate method of getting that 100 degrees is, well, QRS is an inscribed angle, right? So that's going to be half of 160. That means that's 80 degrees, and these are supplementary. So that's a way to get 100 degrees like that. Everything checks out. And that's going to be our example of the day. So look out for the homework, and that's going to be it for today. So again, we got a lot of theorems. Just try to keep them straight. Use your notes as you need them for the homework. But eventually, hopefully, you start getting used to these theorems and you can remember what's what. So I hope you guys, again, or the test is over. Hope you guys are okay with it. I'll get those back soon. In the meantime, stay safe and take care, guys.